Hello folks, this is Mr. Lowe. So once again, I'm going to finish up the Unit 2 notes with the last two examples that we didn't get to towards the end of class, and that is writing a linear function for parallel and perpendicular lines. We will go through this part again on Monday just to make sure we're all on the same page, but parallel and perpendicular lines. So remember, parallel lines have the same slope. So if one line, for this example, the blue line has a slope of 1/2, the red line has a slope of 1/2. So if it's parallel, they have to have the same slope. Perpendicular lines have opposite and reciprocal slopes. So notice the red line has a slope of -2/3. The blue line has a slope of +3/2. So opposite, one is positive, one is negative. Reciprocal, the slopes are flipped over versions of each other. So that's important to know when we go to write our actual functions. So how do we go about writing equations for parallel and perpendicular lines? First step, rewrite the equation into slope-intercept form if it's necessary for you to do so. Step 2, identify the slope of the equation given to you. And then step 3, find the parallel or perpendicular slope depending on the problem. So if it's a parallel slope, you use the same number. If it's perpendicular, you make the slope opposite and reciprocal. So let's look at steps 1, 2, and 3 with example 5. Write the equation of the line that passes through 8, -3 and is parallel to y equals 3/2x minus 1. So that's what we're working through there. So first step, we don't have to rewrite that function. It's already set up and ready to go. So the slope that was given to us, is 3/2. If we want a parallel slope, then we keep the same value. So that's also 3/2. So we've got two 3/2s. So step 1 was to rewrite, we didn't have to do that. Step 2, identify the slope that was given to us. Step 3, make it parallel. So we already had that taken care of. So keep this part in mind here. Do not use anything in the starting equation anymore after this step. So now that we know that we have a parallel slope, we don't need that first equation anymore. Now we're going to write the new one. So we don't need the first one anymore because we have the slope that we need. Step 4, use point slope formula. So this is our point slope formula. Plug in the parallel or perpendicular slope for m, which was 3/2. The given x value for x1, so that was the 8. So remember, the first x stays the same, the second x becomes the number. And the given y value for y1. The first y stays the same, the second y, we plug in the number. So now everything is set and ready to go. And lastly, simplify the answer back in the slope-intercept. So 2 negatives turns to a positive, so y plus 3 equals 3/2 parentheses x minus 8. Then we distribute. 3/2 times x is 3/2x. 3/2 times 8 is 3 times 8 is 24. 24 divided by 2 is 12. And we subtract 3 on both sides. So y equals 3/2x minus 14. and that completes the parallel problem. So again, first step is to rewrite the first equation, which if you don't need to rewrite it, that's even better. Step 2, identify the slope that was given to you. And then step 3, write the parallel version of that slope. Then step 4 is to plug in the slope and the point that they provided for you. And then all of this here is step 5. So that's how all the 5 steps work. It's not a hard problem. It's just one in which you have to pay attention to what you're doing. So that's for parallel. Now, perpendicular. Now perpendicular. So write the equation of the line that passes through -10, -3, and it's perpendicular to y equals -5x plus 2. So, same process here. We start with the equation they gave us, y equals -5x plus 2. There's nothing that we need to rewrite because we already have an inslope-intercept point. So first step is taken care of. Step 2, identify the slope that's given to you. So it's -5. We're going to go ahead and put it over 1 because of what we're going to have to do next. If your slope isn't a fraction, go ahead and make it a fraction. Perpendicular slope. So perpendicular slope is you change the sign and you flip the number. So you make the negative positive, and you take 5 over 1 and you make it 1 over 5. Opposite reciprocal. So we've taken care of the first 3 steps. So now we use the perpendicular slope and we use the point that they gave us to now finish this problem off. So let's keep it going. Y minus y1 equals mx minus x1. First y stays, the second y, we have -3. Our slope is positive 1 over 5. The first x stays, the second x becomes -10. So y minus -3 equals 1/5, parentheses, x minus -10. So we're set and ready to go to finish this off. So remember, 2 negatives can't stay next to each other. So 2 negatives will turn into positive. So y plus 3 equals 1/5, parentheses, x plus 10. Then we distribute 1/5 times x and 1/5 times 10. Y plus 3 equals 1/5 x. 1 times 10 is 10. 10 divided by 5 is 2. And then subtract 3 on both sides. So y equals 1/5 x minus 1. And that's our perpendicular line. So again, it's not a hard problem, but it is a problem in which you need to pay attention to what you're doing and that you have to pay attention to what you're doing. So this completes all of the notes for unit number 2. As I mentioned in class, we will go over this again on Monday. Take the first part of Monday just to clean this up before we move on into unit number 3. But now you have this in case you want to go ahead and get that early start. Let's take advantage of the opportunities that we have, and of course, ask questions if you need them. Have yourself a great rest of your evening, and I'll talk to you soon.